What's going on? I'm Dominic Camper.
And I'm TJ Zook.
And
we're a part of Thrill Seekers Incorporated. We love doing crazy stunts, and there's nothing crazier than traveling through a black hole. And that's just what we're about to do.
So now that you know what you're in for, strap in and prepare for your mind to be blown!
So what is a black hole, Dom?
Well, it's an incredibly dense object that is so massive, not even light can escape it. Black holes can be the size of an entire solar system, or even as little as an atom. Einstein actually predicted black holes when he came up with his theory of relativity.
Actually, Dom, there's a lot more to black holes than even just that.
Really? Tell us all about it, Zook.
Well, Dom, black holes have enough matter and gravity to bend space-time to its breaking point. However, they're also the most basic representation of gravity in the entire universe. As we all know, gravity is a force that is directly proportional to the mass of an object. Furthermore, when we're assessing the gravitational force of one object on another, we must also factor in the distance between these two objects. Therefore, the force between the two objects is inversely proportional to their distance away from each other. When we put these two concepts together, we get Newton's law of gravitation. Black holes push Newton's law to the absolute limits. Because black holes are so incredibly massive and dense, the force between a black hole and another object is simply incredible. So large that even light cannot escape its gravitational force. Einstein's theory of relativity actually shows how the gravitational field of the black hole creates a complete distortion of spacetime. Compared to our Earth, the black hole's distortion of spacetime is magnified tremendously. Therefore, any object that comes near the black hole will be sucked into its gravitational field with so much force that the chances of escaping it are impossible.
Okay, Zook, now that we know a little bit about black holes, how are they formed?
Well, Dom, black holes form from the death of a large star. And to understand why, we're going to have to understand the physics behind a star's life cycle. Stars maintain their spherical shape due to a constant balance between the force of gravity and a force created from nuclear fusion. Nuclear fusion happens when atoms moving at extremely high velocities and temperatures collide with one another to create an entirely new atom. This process releases an incredible amount of energy outward, which is why stars don't actually collapse on themselves, which can be represented by this balloon. So the balloon itself, it represents gravity, which is holding everything together. And on the inside, we have nuclear fusion, which is represented by the air. The air pushes out, and the balloon pulls in, and therefore we get the spherical object.
So, over time, nuclear fusion creates heavier atoms which sink to the core of the star, while lighter atoms such as hydrogen and helium continue to collide with one another at the surface. When giant stars run out of fuel, such as helium and hydrogen, to create this nuclear fusion, the gravity from the dense center causes the star to collapse into an incredibly dense object. Black hole.
So Dom, now that we know about black holes and how they're formed, I think it's time we go and visit one.
But how and where?
Well, scientists did just discover a black hole that's in our own galaxy, and it's only 1,600 light years away.
Like I said, how could we ever do that?
Well, we were talking to Benny earlier, and he was saying that he could build a spaceship that's faster than the speed of light.
I do remember Benny saying that.
And he was pretty excited about building that spaceship.
Oh, very excited.
I could build a spaceship. You're not gonna say no?
Build away, whatever your name is.
Hey guys.
What's going on, everyone?
How you doing?
This is Dom and TJ coming at you from the Thrill Seeker.
Seeker.
And it's Benny's ship that he built.
Thank you, Benny.
He was pretty excited about building it.
Very excited.
And everything looks good. We just got out of Earth's atmosphere, and we're about to embark on a journey that no one has ever done before. And so, Dom, where are we going?
Well, we're going to V4641 Sagittari. It's a black hole in the middle of our galaxy, the Milky Way. It's estimated 1,600 light years away, but thank you to Benny and his awesome spaceship. We should get there in a year. You're alive, hopefully.
Yeah, hopefully alive. That's the biggest thing. Yep. So once we get out there, or alive, that is, we're gonna be the first ones to observe a black hole with our own eyes.
Yeah.
So that's priority one, and then maybe we go for the big thrill and actually try to dive into the black hole and see what happens. So right now we're about to embark on that journey. We're going to be out of communication for a year while we're speeding through space, through the Milky Way.
But we promise as soon as we make it, and when we do make it, we'll be back in contact with our guys down there and, hopefully let you guys in a little bit about the black hole. So.
Show you some videos of the big thrill. So that's the plan. And until then,
this is Dom.
This is TJ.
Signing off. Hey! We made it.
And we made it alive, which is a good thing.
Great thing.
And 362 days later, we've decided that we're going to embark on the journey into the black hole.
We're going for it all.
And at each notable point in our journey, we're going to take videos of our experiences, see if we can send back anything cool on our way.
So our first notable point that we're going to come across as we go through the black hole is the event horizon. And the event horizon is the point where everything, and I mean everything, even light, is sucked into the black hole.
So I've decided that we're going to show you kind of some cool things that are going to happen at the event horizon, particularly dealing with light. So we're talking about the event horizon, and which is this black circle right here. So everything on the inside of the circle is black, aka the black hole. And everything on the outside of the circle is still visible. We can see the light. But something really cool happens right at the edge of the black hole event horizon. Light itself actually orbits around this black hole, so that theoretically, Dom, if we're down there at the event horizon, the light from the back of our head would actually orbit around the black hole, and we would see the back of our head at a distance equal to the circumference of the black hole with our own eyes.
It's a head scratcher. Hey guys, quick update here. We just passed the event horizon, but unfortunately we could get no pictures of the back of our heads because the circumference of the black hole is just too large. But we are moving on. The next thing we're expecting to experience is tidal forces on our bodies. So, Taylor, what are tidal forces?
Well, Dom, tidal forces, as we know, are experienced when the moon actually pulls on the surface of the Earth. So on the front side of the Earth, we actually have a pull towards the moon, and then on the other side, the force of gravity is much less due to the moon, so the Earth actually expands on the backside as well. But when we're talking about black holes, with such a massive object, the forces differ so greatly that even the distance from the top of our head to the bottom of our feet will experience tidal forces. So actually, as we get closer to this black hole, we actually might separate, and that's probably when we'll cease communication. But, it's been worth it. And we'll let you know. We'll try to get you some footage of that, but I don't know if the communication will pass through. But all right, everyone, this is it. We're starting to feel the tidal forces on our body, and I don't think we're gonna make it. There's not a chance we can escape this black hole, but it's been real fun.
It's been a great run, guys.
Thanks for watching these. Ah!